Hello, this is Nick of Time. Welcome to this, our 22nd talk in the series on the physics of time. Again, we will give a short argument that shows why we need to move from the relativistic view to the physical and absolute view. We have to do that for two reasons. One, to be in sync with what the empirical data is showing us, and number two, to give an accurate view of what's happening physically. Okay, this first bullet is the same as we used last time, and it's a very important point. I've used it for decades, but I haven't seen it used by other people, but it's a very useful fact when you're debating this issue or trying to construct logical arguments. The empirical data shows that all clocks at rest in the same frame, other things being equal such as gravitational potential, have the same clock rate. And again, because that's a fact, the International Standards Committee is able to define standards for time, such as the standard for a second. All right, the second bullet says, special relativity claims that all frames are indistinguishable. And note that the velocity or state of motion defines a frame. Okay, let's look at the third bullet. We're going to assume that the special relativity time dilation can explain physical clock rate changes as a function of velocity and see where that assumption leads. We're going to show that it leads to a contradiction. Okay, applying that assumption, we'll look at bullet 3. If we take a clock from frame A and move it to frame B, both frames being in deep space, then we'd have changed that clock's velocity and hence its clock rate. So when the clock goes from frame A to frame B, it'll have a different clock rate when it's at rest in frame B than it had when it was in frame A. But from the first bullet, clock rate is a property of a frame. So that would make frame A and frame B distinguishable one from the other because they'd have different inherent clock rates. And that's a contradiction because special relativity is built on the claim that all frames are indistinguishable. Okay, we're going to look at a similar argument on this topic, but it actually makes a different point. So you're going to get two arguments for the price of one today. Same topic, but, we're going to keep the first two bullets. We're not going to go over them again, but in case you haven't committed them to memory, just for convenience so you won't have to rewind to the previous slide, we'll have them there for reference. Again, we'll look at the third bullet. And again, we're going to say, let's assume that special relativity's time dilation can explain physical clock rate changes as a function of velocity and see where that leads. And again, we're going to see it leads to a contradiction. Okay, if we take a clock from frame A and move it to frame B and then move it back to frame A, it will have undergone, according to special relativity's time dilation, if applied consistently 2 cumulative clock slowings, the first going from A to B and the second from B to A. But that would make it slower than other clocks in A, which contradicts the first bullet, which is established by the empirical data, that all clocks in frame A need to be going at the same rate. And again, frame A and frame B are in deep space, have no other influences, so velocity would be the only variable. So again, we've given arguments that show we need to go from the relativistic to the absolute in order to see what's really happening physically. And it also happens that we need to do that to match the empirical data. And if the relativist is willing to accept the empirical data and go into the critical thinking mode, you'll have to come to these same conclusions. So thank you for joining us today, and hope to see you next time.